Hi, welcome to chemmasters.online. Get mobile app CHEMMasters from Google Play Stores and get registration to get sample videos. And if you are interested, get a course on CSIR net June 2018 and also on Gate Chemistry. Now, we are discussing on Gate previous year solved problems. Just look at the given problem. The geometries of nickel complexes are given with two different ligands, that with CO and one with chlorine. Okay, so we need to find the correct geometries of nickel tetracarbonyl and tetrachloronickelate. Okay, right, so we have given with options tetrahedral and square planar and tetrahedral, tetrahedral and tetrahedral, square planar and square planar. First consider nickel tetracarbonyl, and in the given complex nickel is in zero oxidation state due to neutral carbonyl. Okay, and the carbonyl is a strong field ligand if we observe in spectrochemical series. Okay, and for this neutral nickel in the given complex, it has 3d8 4s2 electrons. Just arrange the electrons in orbitals d as p. Okay, and here due to the strong field ligand carbonyl, the electrons in s orbital can enter into d orbital because d containing two lone electrons in it. Okay, so to make it completely pair up, the two electrons from the s orbital enter into d. Okay, that is due to strong field effect of carbonyl. Okay, so after the rearranging the orbitals with electrons, then we have four empty orbitals. That means simply on s orbital and on p orbital. Then the four carbonyls can coordinate with those empty orbitals of nickel. Okay, and in this if we observe, so it is simply Sp3 hybridization, and there is no free electrons or lone electrons. Okay, so with Sp3 hybridization without lone electrons or single electrons, then the structure is tetrahedral. Okay, right, and the d orbital is completely filled with electrons or d orbital with paired electrons. Hence the total nickel tetracarbonyl complex is considered as diamagnetic. Okay, right, now check for nickel complex with chlorine ligands. Here in the given complex nickel is getting +2 oxidation state, hence the valency electrons on nickel as 3d8 4s2 because due to the loss of 2 electrons due to the presence of nickel +2. Okay, right, and here the chlorine is considered as weak field ligand. Okay, now just arrange the electrons in orbitals. In d orbital 8 electrons are there. Okay, and in s orbital and p orbitals are 0 electrons are there due to +2 on due to the loss of 2 electrons on nickel. Okay, right, now the electrons doesn't pair up in d orbital. In d orbital we have two unpaired electrons, but they cannot pair because due to the presence of weak field ligand. Okay, hence the four orbitals, that means from one orbital from s orbital and three orbitals from p orbitals, involves in hybridization. Okay, that means involves in coordination with incoming chlorine ligands. Okay, that means the 4 chlorines enter into the empty orbitals of s and p orbitals. Okay, hence we get sp3 hybridization. And in sp3 hybridization there is no unpaired electrons. Whenever we have sp3 hybridization with no unpaired electrons, it is simply tetrahedral. Okay, but if we consider the total complex orbitals, then d orbital is containing lone electrons, okay, or single electrons. Hence the given nickel that means the tetrachloronickelate anion is simply paramagnetic due to the presence of unpaired electrons on d orbital. Okay, right. So simply the given geometries of nickel with carbonyl as ligand and nickel with chlorine as ligand, the geometries of two complexes are tetrahedral and tetrahedral. Okay, so answer is option C. Thank you.